our goal is to create triphenyl methanol from benzophenone by reacting with phenylmagnesium bromide. Am I right?
Mm-hmm.
Okay, so I understand if the start of the procedure is a little bit confusing, and I'll go over that to hopefully clarify if there's any part of it that's not clear enough. Because the way the lab is designed is they first make the phenylmagnesium bromide, which was my plan also, from phenyl bromide by reacting it with magnesium. And then once you make the Grignard, then they were going to add the ketone to convert that into a tertiary alcohol. That was the plan. Although we are not, because of time, we are not able to do this part. So we are just basically going to use pre-made Grignard and do the reaction. Does that make sense, everybody? Okay, cool. The mechanism, I know we just did this yesterday in class. So, what's the mechanism? Anybody? First step?
Phenyl goes to the C-double-O.
So the Grignard provides us with electron-rich phenyl, which goes and attacks the electron for carbon,
The
right?
electrophilic carbon.
Nucleophile attacks the electrophile. What does that do? Creates.
And alkoxide.
Now, does this have a leaving group? Remember, H's never are leaving groups, R's are never leaving groups. So does this have a leaving group? So that's
No.
the end of step number 1. What's the purpose of step number 2?
The pronate.
Protonate the O minus, make the alcohol. Isn't that right, everybody?
Yep.
Okay, cool. I did ask you to, can I erase this? Because you have it, right? I did ask you yesterday to do a little bit of math. And the idea is that the phenylmagnesium bromide that we are using, the Grignard that we are using, it's a 3 molar solution. And it's dissolved in ether, diethyl ether. Okay. So the molarity we know. How much of benzophenone is the procedure asking us to use in this?
1.09 grams.
1.09 grams. Is that correct, everybody? So the question I had asked you is, if we know we're using 1.09 grams of benzophenone, how much of this solution would you need, looking at stoichiometry and everything? Has anybody done the math for that?
Yes,
Yeah.
we did.
1.997? You sure? Sounds a little low to me. Why did I get 2.2? What's the molar mass?
182.23 grams per mole.
77
1.8.
plus 77 plus 28. Plus 77 plus 28, right? 12 plus 16. 182? Something?
Yeah,
Something?
182.23.
So 1.09 divided by 182-ish, about 0.30. Good, and then 3 molar, so mole divided by 3. Oh, okay, you're right. Absolutely, yeah. Cool. So about 2 milliliters. Maybe I did something wrong in my math when I was, because I got 2.2. Everybody's getting that? Now I will need to dispense this for everybody because it is, remember we were talking about in lecture that this is an extremely strong base. It is such a strong base that it will also react with what? Can also react with
Moisture.
from
The air.
anywhere, right? Including air. So we can't expose it to air. By the way, what will be created if phenylmagnesium bromide reacts with moisture in the air? What will get created? Say that again? Not in this
Benzyl alcohol.
What's the role of this guy? To react as a what?
A nucleophilic R group.
But in this case, what will this react as? Is this electron rich, electron poor?
Electron rich.
So if it's electron rich, it can do 2 things. What are those 2 things? That anything that's
Nucleophile and base.
Nucleophile does what kind of reactions? Substitution.
Substitution.
Are we looking at substitution here?
No.
So what is the other purpose of an electron-rich entity? It
Base.
acts as a base. What does a base do?
Elimination.
Okay, yeah, but not in this case, right? What does normally a base do?
It accepts protons.
Takes a proton. Where's the proton coming from?
Water.
So if the base takes a proton, which is acting as the acid in this case, of course it's a weak acid, but that's such a strong base that even a weak acid like water can give a proton. What does the phenyl become? Louder, please. Somebody said it somewhere there.
Benzene.
Exactly. And of course we get the inorganic stuff, which we don't care about, but the point is that the R minus is taking a proton and becoming, getting that hydrogen back. Does that make sense, everybody?
Yeah.
So coming back to the point, yes, Mark?
That PHH means benzyl? Like,
Benzene.
I haven't seen
Not benzol, benzene.
Benzene.
the PHH,
pH is phenol.
phenol.
What does pH
And then the
stand
H,
for?
Phenol.
I'm sorry, I haven't seen that.
No, you have. Phenol is, you've seen phenol.
No, I've seen phenol, I mean,
You've
not the,
seen benzene too.
no, I've seen both,
Oh.
but the PHH is my confusing.
Well, what is this?
Our
The organic.
organic
Alkyl.
alkyl group.
If I put a hydrogen on it, what does it become?
Alkane.
Same thing. All I'm doing is I'm taking the phenyl group and instead in that position I'm putting a hydrogen on. Isn't that benzene then?
Yep.
Got it.
Right? Agree?
Mm-hmm.
Do you see it?
I see.
Right?
Thank you.
Yeah, and it does. Benzene is this example because we are using phenol, which takes an additional hydrogen, so becomes. But then whatever that guy
Okay.
was, whatever that was. Okay. So coming back to the main point though, because this is such a strong base, it cannot be exposed to air. Therefore, the container you will see is sealed under nitrogen. So it needs to be used in a certain way to get the solution out without too much exposure to air. So what I will need from everybody, please listen to this very carefully. What I will need from everybody, and this has to be done together. Once I start doing that, I can't stop because again, this whole exposure thing. So what I will need from everybody is to have a dry round bottom flask. Maybe the big one, maybe the 25 milliliter round bottom flask with a cap. Very, very important. And a spin vane in there. You will bring this to me and I will dispense out maybe about 2.2 milliliters because we don't want this to be the limiting reactant, we want that to be the limiting reactant. So I'll give you more than 2.0 milliliters so that Grignard is in excess. Make sense, everybody?
Mm-hmm.
And then I will put Grignard in here and we have to immediately close it. As soon as the Grignard goes there, you've got to close it. Otherwise it's being exposed to air. Does that make sense?
Mm-hmm.
Now before you do that, before you do bring me a round bottom flask to get your Grignard, make sure that in a conical vial you are taking benzophenone and dissolving it in how much ether did they say?
2 milliliters of anhydrous ether.
Dissolve it, keep it capped. Very, very important to make sure this is, so make sure you have this solution ready. Then you come and get this from me, and as soon as you get it all into your hood, using a syringe, and I'll show you where they are, you will start adding to the round bottom flask. Make sense?
Mm-hmm.
And then the procedure says don't add too quickly because it generates heat and diethyl ether is extremely volatile. So add it, maybe, how much did they say to add at a time?
A few drops at a time.
A few drops, I thought it was more. But that's okay. The point is, please don't just add all of your benzophenone solution in there at the same time. That will create a lot of heat. So maybe a little bit at a time, keep on adding. Never open this cap. Never open this cap. You can open this cap for a very short amount of time, very quickly use syringe, take some, close it right back. But this one, please do not open. This is going to have a septum, and the purpose of the septum is that the needle goes right through the septum. So you don't ever have to open that cap. Everybody okay?
Got it.
Yes? And then of course we are going to try and keep stirring at the same time, but eventually or very soon you'll realize there'll be so much solid in there that the stirring won't work. That's okay, don't worry about it, just make sure all of this gets added. Wait, just one more thing, then I'll ask. Everybody okay so far? Now something that I think you must also do, once you've added all the solution into the Grignard, please take some ether. How much? Who cares? Doesn't matter. Take a small amount of ether just to rinse and transfer it in here as well to make sure all the benzophenone becomes part of that flask. Does that make sense, everybody? Yes.
Are we heating it at this point?
So, I think the heating part was before when we were making the Grignard.
Okay.
Once you've made the Grignard, I don't think you need to heat it, but it will create its own heat.
Okay.
So this thing will get hot. So you do want to be careful about that.
So we're not doing like the whole apparatus setup where it's being heated. Is this at the
Is
beginning?
there heating? Did I
It
say
says
something?
while it's being heated for reflux in the apparatus, then
That's
you
this part.
That
Okay.
was the,
Yeah,
I
but
guess
we
that
are
was
not
the
doing
synthesis
that.
of it.
Right? Am I right, guys, or am I remembering wrong?
Yeah.
Please let me know if I'm remembering wrong.
I just wasn't sure if we were
Yeah.
refluxing it for a different reason.
So that was coming from the previous thing here, but once we have that, I don't think we need to reflux this. Did you have a question, Mark?
Yeah, just to make sure I don't ruin it. You said clean with a little ether, this one, and then put it
Yes,
in that one,
To make sure all of this goes in here.
and then put it in there
Yes,
with the.
Yeah.
yes, we
Okay.
want all of benzophenone in here,
Okay, thank you.
because that's your limiting reactant. Everybody okay?
Mhm.
So was there reflux for this guy?
It said at the very beginning, it just says
Very
while
beginning.
it's refluxing. at
Yeah,
the
then
end
I
of the
think they're
video.
talking about this now, sooner.
The end of that. part.
Everybody okay?
Yeah.
Now, once that has happened, and hopefully you've got this pinkish looking milky solid, hopefully that's the hope, we'll see how things go. Then it is okay to open it up. Because hopefully by that time, all the Grignard has reacted. And we don't have any more Grignard left over. So at that point onwards, it is okay to open, let it expose, totally fine. Because anyways, you're adding aqueous HCl after that, aren't you?
Mhm.
You're adding water to the system anyways. So after you've added all the benzophenone, you're going to get the alkoxide ion, and then we are protonating it by adding, what is it? It's hydrochloric acid, isn't that right?
6 molar.
6 molar
molar
HCl.
hydrochloric acid, exactly. So you're adding water anyways after that point, so it's okay to open this thing up after that. Does that make sense, everybody? Yes, yes.
You might go over this,
Yes.
but I was reading that we may need to add more ether
Yes.
or hydrochloric acid.
That's, yes, I do wanna talk about that. So, at this point, you will end up with 2 layers, hopefully, because remember we had ether coming from here and then ether coming from here. And if you remember from last quarter, diethyl ether is not very polar, so it doesn't mix with water. You're adding water right here, so we will have, hopefully, we will have 2 layers. Which layer will be organic and which layer will be aqueous? Anybody?
Top is organic.
Louder?
Top is organic.
Exactly.
Bottom
Ether
is aqueous.
has lower density than aqueous, so hopefully ether is on the top and on the bottom. So at this point in time, if it feels to your system that there is this solid sitting right here, right in there, this white solid which is right in the middle of the 2 layers, that tells me that you don't have enough ether. Add more ether. How much? Who cares? Doesn't matter.
Add enough.
Just add more ether. Now if let's say you're adding ether but it seems to make no difference to that solid stuff, what do you think? Then add more water. Actually, just water, not even acid, just add more water. The point is, the two layers have to be clear, no solids. If you're getting solids, it's because one or the other solvent isn't enough. Add more, a little bit more, till you get them to be absolutely clear. Make sense, everybody? And then we are transferring all of this into a new piece of glassware called a separatory funnel. Am I right? Now, separatory funnels are great actually. And most research labs use separatory funnels to do extractions and not what we have been using so far. This is a SEP funnel, separatory funnels. Over there, they're all over there. Please make sure that when you are when you're done using one, clean it, give it back to us. Now, when you do get a SEP funnel, make sure it has a cap that doesn't leak. How would you know that it doesn't leak? Well, put some water in it and see if it leaks or not. Okay, so we want to make sure that the lid fits really well so there are no leaks. By the way, perpendicular is closed, parallel is open. Perpendicular is closed, parallel is open. So please make sure before you start using your SEP funnel, please make sure there are no leaks. If there are, go with a different lid to make sure you have one without leaks. Everybody okay? You will need a ring stand, but this is a special ring stand for OChem people. Gen Chem people don't get to use this. So don't share with Gen Chem. But please don't share with Gen Chem. That big blue bin, this not big, this blue bin right there has the O-rings that we need. Could you please not mix these O-rings with the Gen Chem O-rings because of the size? Those are smaller ones which we need, so we need to make sure we have them. So how does this work? Well, it works. I'm just going to put two, not tap. Can you guys just close your eyes? Okay. Water, aqueous layer. Who cared? Oh, shoot, I should have done that first. Please, could you hold for me? I was only born with two hands, unfortunately. Sometimes you're like, I need more hands. Okay. You might want to use ring stands that are under the sinks because you don't have these inside your hoods. So you will need, oh, these are actually too big. Okay, those are too big. Are they here? Yeah. There might be more over there as well. So a ring stand with these clamps, because then it supports the separatory funnel. So the ring stand basically supports the SEP funnel. So we need that size. We good, everybody? Now, of course, you're going to have two layers because there's an organic solvent and there is an aqueous solvent. By the way, Carter used a word before called anhydrous. What does that mean?
No water.
Dry, right?
Yeah.
So what do you think will happen if I take this ether bottle and leave it open?
It'll get exposed to
So
moisture.
let's not do that. A, it's very volatile and the smell of ether will be in this room the entire time, and some of us like me will get a headache. Ether just, for me, it just goes right in my head and I get a headache. That's point number one. Point number two is it's not going to be anhydrous anymore, so it's really going to have an influence, could have an effect on our experiment. So please, if you open this, you must close it. Can you smell the ether? Anyways, the point is, you got two layers, right? What do we have to do when you're extracting? If you can think of whenever you've done extraction, we got to mix the layers, right? This is where the SEP funnel is wonderful because one finger to hold the cap, or maybe two depending on your style, but one hand handles the separatory funnel. Please make sure the cap is always being pressed down, and we mix the layers. and vent. Because ether is so volatile. But vent happens here. So mix, 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 and vent. And when you're done mixing enough number of times and venting enough number of times, and then you're ready for the layers to separate, that's when you let it sit in there. So the layers will separate. And then we are ready to separate. Which layer are we going to remove?
Aqueous.
So whichever is the bottom layer. In the SEP funnel is designed to not remove the top layer ever. It is to remove always the bottom layer, because all we can do is we can just go ahead and open this thingy and start draining out the bottom layer. Make sense, everybody? Yeah? Now, eventually, it stopped draining. This has happened to every single person of us. We've all had this instant. If anybody says they never made this mistake, they're lying because they're too embarrassed to admit. What am I doing wrong? I have that open, yet it's not draining. Why is it not draining? Anybody? Caps on. So who said that? Was it you? So what? But you're absolutely right. It's creating a vacuum in there. There is no place for the liquid to come out from. Did you notice the bubble just go up?
Yeah.
So, by the way, this
Yes.
has happened to all of us. And then you sheepishly like, oh shoot, I forgot. And then you go on. Make sense, everybody? Happens all the time. So just keep in mind, and very carefully now you can remove the bottom layer, because you can actually see the separation really, really well, and leave the top layer in there, and then do whatever you need to do with the organic. In this case, we are lucky that the top layer is what we want, because that's the organic layer. But that's how SEP funnels are intended to be used. Make sense, everybody? Are you all good with the SEP funnel? Yes?
So if we actually make it too much of our top layer down, we just go dump it back in and redo it? That will?
Yes? The only tricky part today is this solvent ether. It's extremely volatile and it's the top layer. So you will see lots of evaporating ether, meaning okay, you won't see it, but ether will evaporate a lot because it evaporates so quickly. So if ever you come to a point where you're like, I don't have enough ether, what should you do? Just add more ether. Done. Sounds okay, everybody? Is everybody okay with the SEP funnel?
Yes.
Okay, I'm going to put it over there because I'm smelling the ether too much. Okay. We are doing extraction with hydrochloric acid, and then what? What else are we doing extraction with? Say it again. Decant. What does decant mean? It just means pour. Decant from where to where?
Either solution is small or
And oh, okay. So decant simply means that you've got the ether solution in the separatory funnel, just put it in an Erlenmeyer flask. Not a beaker, actually Erlenmeyer is better because it has a smaller mouth, smaller opening, so evaporation is a little bit slowed down than a beaker. So absolutely. Isn't there a petroleum ether step anywhere?
Oh, yeah.
Yeah, there's a
Yeah.
There's a
petroleum.
petroleum ether. What, by the way, please, ether, this is ether. Diethyl ether is not the same thing as something called petroleum ether. In fact, petroleum ether is actually not an ether, even though we call it pet ether. Petroleum ether is a mixture of alkanes. It's a mixture of a couple of low boiling alkanes, hexane, pentane, all of those mixed together is called pet ether, petroleum ether, so on and so forth. So it's really not an ether. Do you expect pet ether to be as polar as as normal ether or less
No,
polar?
less polar.
Because those are just alkanes. The reason I'm bringing this up is we don't have, I think Pete just told you this morning, we don't have enough pet ether. So we are going to be using hexane instead, and that should be okay. Because really pet ether is hexane and pentane and all mixed together, so it doesn't really matter. So if you see we don't have pet ether, that's okay, just use hexane for the same purpose, same goal, should be okay. Everybody okay? Cool, yes, Carrie.
Before that step, it says to prep a warm water bath with a nitrogen stream. Are we?
We're going there. That comes later, doesn't it? When you rinse with pet ether, you will have solid that you will filter out under aspirator. Am I remembering correctly? And that solid is your product. The petroleum ether, by the way, is to dissolve the impurities. It should leave your product as a solid, the impurities get dissolved. So then the solid product can be filtered off, separated from the impurities. Does that sound right?
Yes.
And then aren't we recrystallizing the solid with isopropyl alcohol?
Yes.
Okay, so depending on the time, I think we can, because this should take us maybe half an hour to maybe 45 minutes and maybe another 30 minutes and stuff to do extraction and everything. I think definitely crystallization is doable. So please do plan to. Everybody looked up the videos and knows exactly how to do the recrystallization we learned last quarter. Everybody? Yes? I'm seeing some faces that I don't know, then you didn't prepare. Because recrystallization is something we've done last quarter. So please do make sure you know exactly what steps to follow for recrystallization. As far as our data is concerned, of course, after the recrystallization, I would recommend though, a recommendation guys, when you have the crude product, what does crude mean? Impure, meaning before recrystallization, get its weight. But it won't be, no, it's coming out of petroleum ether, so it will dry very quickly. Let's get its weight and IR, quick solid IR, and save a little sample for melting point. So you can save a little bit. Tiny, maybe even put it on in a capillary tube and save it for yourselves. Do you guys remember melting point from last quarter?
Yes.
So remember how little it takes to do that. So maybe do that and then do your recrystallization from isopropyl alcohol. Boiling isopropyl alcohol. Always use boiling solvent. That's extremely important. When you get your pure compound, pure product, then of course you're going to dry it and get its weight, get its melting point, get its IR. So you'll have two IRs, one for crude, one for pure, and the third IR for the reactant, benzophenone, so you can do comparisons. 3 IRs. Everybody okay?
Mm-hmm.
2 melting points. Melting point for the crude, melting point for the pure. And then percent yield. Okay? No NMR today. Everybody okay with that?
Mm-hmm.
In terms of your discussion, what are we looking for discussion? Exactly what we've been doing so far for the other experiments. Percent yield, where's the loss? Where could we have lost the product that you lost, if you did? So please discuss your percent yield and loss. Also discuss the IRs. What's the purpose of comparing the IRs? What will that tell us?
Whether the reaction was successful or not.
Agreed? Everybody? And what about melting points?
Whether it's pure or not.
Pure or not, exactly. So please look up literature melting point as well. So you should report 3 melting points to me. Of course, the literature melting point of the product, the crude melting point of the product, and the recrystallized melting point of the product, which then helps us figure out if our recrystallization worked. It's Do we have the pure product or not? Everybody okay with that? Make sense? So that's what we should have in terms of data, in terms of results from this experiment. No NMR. Questions? Yes. 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 Oh, yes. Oh, yes. Now I remember where Terry was. Thank you, Anika. Yes. I think once all your extractions are done, you're taking your organic layer in a, you said decanted in a, you don't have to decant it, you can just open it and it pours out. And then yes, use drying agent and then evaporate the ether. We've used that thingy over there, right? The warm water bath with nitrogen. Everybody remembers that? I will start that so that it's warm when you're ready. Let me know when you need it so I can turn the nitrogen on. Yes, thank
So
you.
we're using that to evaporate the ether.
Yes.
Okay.
And then you get the solid which you wash with petroleum ether or hexane. Am I remember right? Which you then filter to get your crude product. Thank you for reminding me. Yes, that step over there. Is that what you were referring to?
Yeah.
Absolutely. Anything else, guys?
Do you have ibuprofen for headaches?
I'm sure I have something. If not ibuprofen, aspirin, or something I should have, and I will go and ask. Maybe Tylenol, or I'll go ask Pete what he has. Absolutely. Anything else, guys? Okay, so here's my dilemma. I wrote the quiz. I printed out the quiz and all, and then I realized I don't think we are ready for the quiz because we are behind in the stuff. So whatever I have on the quiz, I think we are not quite there yet. So I'm suggesting we postpone the lab quiz a bit. I don't know till when yet. Maybe tomorrow, maybe next week, we'll see. Is that okay with everybody? Yes? Sure?
Like if it was tomorrow, what, in the class?
I haven't figured that out.
Okay.
I'll be honest, Smart. I haven't been able to figure out all of that. But whatever we do, we'll try and do so it works for everybody.
Okay.
Absolutely. Is that okay with everyone, or is someone objecting to it pretty strong?
Perfect, because, yeah.
I think so.
I didn't feel
So
prepared.
I think the lab quiz might need to wait a little bit. Okay, in that case, we are ready to start the experiment. Now, one thing that I